Okay, let's take a look at problem number 6. Okay, this is a relatively more challenging question here. So giving you the total number of male students and total number of female students for undergraduate, and the percentage of male getting financial aid, percentage of female getting financial aid, and out of this percentage of who getting financial aid, there is this much of the 44.8 for getting federal financial aid, and 50.4 getting federal for female. First question is, what's the probability of male student without aid? Second one is a student who receives federal aid. Third question is a male student, given that the student has aid. So as usual, I suggest you draw a tree diagram here. Okay. So for example, given a randomly selected undergraduate student, and there's this much percentage and this much percentage for being a female and male. And if it's a male student, this percentage of getting financial aid, this percentage getting financial aid, and then there's another branch here for getting federal aid. So there are 4 levels here, okay, for the tree diagram. Compared to the previous one, there are actually only three levels, right? Okay. I put on some labeling here. So this number represents the probability of male, probability of female. And this number is the conditional probability, so that's the probability of getting financial aid when it's male student, probability of getting financial aid to female students. And this number here, right, is basically the probability of getting federal aid when you have a male student with aid. So technically speaking, you can write probability of federal aid. So let's see if I call a student with federal aid. So this is basically totally, right? This is, I can call that student with financial aid. Okay, so student with financial aid under what? Under a male student with aid. So male student with aid. Okay, so this is PSFA under a student with a female student with aid. Okay, yeah, so that's how you can do that. Okay, yeah. So let's go back to the question. Let's see the first question here. Okay. So what's the probability of a male student without aid? So let's look at this diagram. Where are we talking about here? A male student here without aid is actually, that's the location here. This location, right? Yeah. So in other words, right, you're looking for, right, a male student without aid. Okay. So let's see. You're looking at this probability of what's the probability that you come into this location, basically, right? Okay, so let's see the first question, right? So we're looking for P male, a male student without aid. Okay. Now, technically speaking, right, how do you get over here? So this is overall, student no aid, right? Student no aids here. And you're talking about a male student without it. So basically what you're looking at is probability of a male and no aid, right? So you're looking at basically looking at this one here, male and no aid, or it's the same thing as we said in the previous, PA and a B equal to PB and A. Okay, yeah. Now this condition here is where you can actually directly apply what? Directly apply the conditional probability, right? Diffraction probability here. This is PA and B, right? Which equal to, right, P male, AA, and multiplied by P, right? And no aid, and male. Okay, so let's see if that makes sense or not. You can also explain it. So basically, the probability of getting over here, right, is equal to the probability of this branch, which is what? Which is no aid, male. Okay, so the probability of this branch multiplied by the probability of this branch here, right? Yeah. So that's why you see this one multiply this, and that's That's how you get actually from the conditional probability too, right? Yeah. Now, second question, yeah, is what's the probability of student who receive what's the probability who receive a federal aid? Okay. So basically, where's the probability of student receive federal aid? Over here, these two locations, right? That's where, so altogether, that's where a student getting a federal aid. So essentially, you need to add up the probability of this location, the probability of this location here, right? That's what we call a total probability problem, right? Total probability problem. So just from the tree diagram, it's actually easy to understand. What's the probability getting here all the way through here? What's the probability getting here all the way through here, right? Yeah. So technically speaking, you just multiply this plus this, and you get the total probability of this, right? So this, you're looking for probability of student getting an aid, right? What's the probability of students getting a federal financial aid? Okay, so that's what you're looking for here. Now, as we said, it's a total probability problem, right? If I look at this one here, right? Total probability. Just look at this one here. You actually remember I said we have 3 levels, right? 4 levels. So we have to go 1 level up here. So probability of student getting an 8, right? So you go 1 level up to this location here, right? Yeah. So then mathematically, right? Probability of student getting 8, right, is equal to what? Probability of total probability, right? Total probability. So probability of SFA under, right, a student getting an aid here. Yes, male student getting aid, and then multiply by the probability of a male student getting an financial aid, and similarly, right, female student here as FA here, and then probability FWA. Okay, so that's the total probability with 1 level up to here. Okay, yeah. Now we know this and this, right? That's from the tree diagram. One is 44.8 and the other is 50.4. Okay, but what about this and that, right? Yeah, so basically this one and this one, right? That you have to go 1 level up here, right? So you're looking for probability here. Male student with financial aid, female student with financial aid. So you need to look at 1 level up over there. One level up. Okay. Yeah. And that's actually basically this equal to what? Probability of aid and male multiplied by probability of male. And this, right, or this equal to probability A female and probability of female. Okay, so once you do that, apparently this is exactly as what I said. The numbers, multiply them together for this branch and add the values for the numbers multiplying all together for this branch, right? The 2 branches at here. So last question, a male student, what's the probability of the male student given the student has a financial aid? So basically, if you have a student having aid, so then what would the probability for that being a male student? So conditional probability. So basically, what's the probability of the male if you're getting financial aid? Or just with W here is with 8 here, right? Okay, sorry, 8 here. Yeah. Bayes theorem. Okay, Bayes theorem here. Bayes theorem according to this one here, that's lower one of with 8. Okay, and P8 male and P female, right? So this is Bayes theorem. So this you have it in the tree diagram. This you have it in tree diagram. But probability of 8 you don't have the tree diagram. So probability 8 here. So now you need the total probability theorem, right? Because you probability having 8 is this plus that, right? So 2 branches. So this number plus multiplied by this number plus this number multiplied by this number, total probability. Okay? So that way you can calculate this one here. Okay, you can calculate this. Okay, so that's number 3. Okay, part 3 of this question. So drawing the tree diagram definitely helps in terms of understanding and having an overall picture. Okay, because sometimes the wording is quite confusing. Yeah. Last question is a random variable, which is a discrete random variable here. Okay, I think maybe the trickiest part is calculating the value of c here. And this is our definition. Very simple. To calculate the value of c, you have to understand is this represents the probability mass function. Okay, and that's what we use for our discrete random variable, right? Because it's discrete here. And you gotta understand that for any probability function, right? If it's discrete, okay, so then you basically the summation of all of those here, the different value of n should be equal to 1. Okay, so otherwise we would not call that probability mass function. So this, using this function here, you'll be able to calculate the value of c. Right? Yeah. So once you get the value of c, then you can calculate this, and that very easily. So probability of n equal to 1, just substitute n equal to 1 and c value, you'll get that. So for probability n greater than 2, right? What does that equal to? That equal to probability n equal to 2 and probability n equal to 3. Okay? Yeah. So for probability of n greater than 3 here, right? For n greater than 3. Now, this has to be a little bit tricky. Is it's not right. This is not probability of n less than 3 here, right? If it's probably less than 3, you actually end up with basically just 1, right? But you're asking what's the probability for n greater than 3. But look at that. When n is greater than 3, there's no probability. There's 0 there. So this is actually going to be 0. Okay, yeah. So that's the assignment number 4. Okay, hopefully this helps. Okay, do it and let me know if you got any questions. Okay, thank you.